In this video, we will look at the oxidation number and how to find out the oxidation number. So you can see the numbers written on the above of these elements. So this is the oxidation number. Okay, and what are the rules for the oxidation number? Let's talk about that. So the first rule is that the oxidation number of any uncombined element is 0. So the oxidation number of any uncombined, or you can say that the element by itself. What does it mean, element by itself? It means that it is not actually bonded with the other element. Let's say if we talk about the sodium, it has 0 oxidation number. If we talk about the zinc, it is not combined with the other element, so it has 0 oxidation number. If we talk about the Cl2, H2 and O2, it has 0 oxidation number. Okay, now let's talk about the other rule, second rule. The second rule is in compounds, many atoms or ions have fixed oxidation number, and you can see that the group 1, all the group 1 element have +1 charge because they can lose only 1 electron, so that's why it has 1 plus charge. Now let's talk about group 2. Group 2 has 2 electrons in the outermost shell, so definitely they will lose 2 electrons in order to gain the stability. So we can say that the group 2, all the group 2 has +2 charge. And if you talk about group 7, they all have -1 charge. Why? Because they have 7 electrons in their outermost shell, so they can gain only 1 electron in order to follow the octet rule. Clear? And what about the rule number 3? So the rule number 3 is the sum of oxidation numbers in a compound is 0, or you can say that in a neutral compound. Clear? So sum of oxidation number in a neutral compound is always 0. You can see over here that the sodium has +1 charge, chlorine has -1, and if we sum up these two charges, you will end up with the 0. Clear? So this is copper oxide, and what is the oxidation number of copper? The oxidation number of copper is +2, and the oxidation number of oxygen is -2, and the sum is 0. And let's talk about the application for this rule. How can you apply this rule? For example, we have copper oxide and you want to find out the oxidation number of copper, and the rule says that the oxidation number, sum of the oxidation number in a neutral compound is 0. We don't know the oxidation number of copper, so I'm going to write down X, and oxygen belongs to group number 6. It can gain 2 electrons, so that's why oxygen has -2 charge. Clear? All the group 6 elements have -2 charge. So if oxygen belongs to group number 6, so it has -2 charge. Okay? So X -2 equals to 0 and X is equals to 2. And you can see over here that the oxidation number of copper is 2. So if the oxidation number of copper is 2 and the oxidation number of oxygen is -2, and you can confirm this thing that the sum of oxidation number in a neutral compound is always 0. Clear? Let's talk about the other example. For example, we have potassium manganate. If we have potassium manganate and we need to find out the oxidation number of manganese. So yes, we can find out the oxidation number of manganese. We don't know the oxidation number of manganese, but we know about the oxidation number of potassium, which is +1, because potassium belongs to group number 1, so definitely it has +1 charge. And if we talk about the oxygen has -2 charge. One oxygen has -2 charge, but you can see there are 4 oxygen over here. So +1 plus X plus -2 times 4, and the overall charge is 0. So 1 plus X minus 4 times 2 is 8 equals to 0, and then X minus 7 equals to 0, and then X is equals to 7. So the oxidation number of manganese is 7. Oxidation number of manganese is 7 plus 7. This is +1, and oxidation number of oxygen is -2 times 4. So sum of charges is equals to 0. You can confirm this. +1 plus 7 minus 4 times 2 is 8. +1 plus 7 is +8, and then -8 equals to 0. Clear? So let's talk about the next rule, which is that the sum of oxidation number of each atom, the sum of oxidation number of each atom in a molecular ion is equals to the charge on the molecular ion. So I'm going to repeat it again. The sum of oxidation number of each atom, the sum of oxidation number of each atom in a molecular ion, this is a molecular ion, okay? So we have the group of atom having charge on it, we can say that this is the molecular ion. So in a molecular ion is equals to the charge on the molecular ion. Now it is not equal to 0, it is equals to the charge on the molecular ion. So we can't say that this 2 minus 2 is basically belongs to oxygen or sulfur. We can say that when we sum up the oxidation number of these elements in a molecular ion, so that sum is equals to the charge on the molecular ion. So the charge is 2 minus. So this 2 minus is because of sulfur and oxygen. Okay. So this is the molecular ion and the oxidation number of sulfur is basically 6. Okay. And the oxidation number for oxygen is -2. So 6 minus 2 times 4, minus 2 times 4 equals to -8. 6 minus 8 equals to -2. And you can see that this charge is because of oxygen and sulfur. This charge is not on the oxygen. Okay. So by using this rule, we can find out the oxidation number of each element in a molecular ion. Okay. So let's say we don't know the oxidation number of sulfur. Let's say we don't know the oxidation number of sulfur. So if we don't know the oxidation number of sulfur, how can we find out the oxidation number of sulfur in a molecular ion? Let's talk about that. So I'm going to write on the sulfate. So oxidation number of sulfur we don't know, but oxidation number of oxygen is -2 times 4. Okay, and the sum of oxidation number in a molecular ion is equal to the charge on the molecular ion. So we need to write on the charge like this. So -2, and then x minus 4 times 2 is 8 equals to -2, and then x equals to -2. This 8 becomes plus on the right hand side, and then you will end up with the 6. So the oxidation number of sulfur is 6. Okay, so let's test this. Let's say if the sulfur has +6 oxidation number and one oxygen has -2, so overall charge is -8, and you can confirm this that when we sum up these charges, +6 minus 8 equals to -2. Clear? So it becomes molecular ion. So this -2, the important thing is this -2 is not on the oxygen. This -2 is basically sum up of the oxidation number of this element and this element. So this is the important point. Clear? Now let's talk about the manganate ion. Okay, let's talk about the manganate ion. Let's say we have manganate and we need to find out the oxidation of manganese. So I'm going to write down x and then -2, because the oxidation number of oxygen is -2. -2 times 4 equals to the charge on the molecular ion. Okay, so -2 times 4 is -8 equals to -1. X is equals to -1 and then +8, and then the answer is 7. So the oxidation number of manganese is 7. Clear? The oxidation of manganese is 7, and the oxidation of oxygen is -2 times 4 is -8. So the overall charge equals to -1, and you can see the charge on the molecular ion, which is -1. Clear? And then while naming, use Roman numerals for the transition metals to show its oxidation number. Why? Because we know that transition elements have variable oxidation numbers. For example, copper has +1 charge, copper also has +2 charge. Okay, so while naming, we have to use the Roman numerals for transition element to show its oxidation number. Let's say we have copper oxide. So we know that the oxidation of copper is +2 over here. So we have to write down copper 1 oxide, copper 2 oxide, sorry. Clear? Copper 2 oxide. And if we talk about this copper oxide, let's find out the oxidation number of copper. Let's apply the rule number 3. So 2x plus -2 sum of oxidation number in a neutral compound is equals to 0. So 2x minus 2 equals to 0, and then 2x equals to 2, and then x is equals to 1. So the charge on the one copper is basically plus 1. So what's the name of this neutral compound? This would be copper 1 oxide. Copper 1 oxide. Clear? So this is copper 2 oxide. Don't write down the just copper oxide, you need to use the Roman numerals. If you talk about the potassium manganate, so manganate has plus, manganese has plus 7 charge. So we need to write on potassium manganate 7 in the Roman numeral. Okay, so this is all about the rules for the oxidation number.